Welcome to 13.1 video lesson underneath Algebra 2. The concept is exploring periodic data, and there are 8 boxes for us to talk about. So let's begin with box number 1. It is all about a bunch of words that we're going to be using for this section. Okay, so a periodic function is nothing more than a function that repeats a pattern of y values. And remember, guys, the y values is the outputs at regular intervals. So that's our definition that we're going to be using for a periodic function. And there are 2 important parts to periodic functions. There's cycle and there is period itself. So a cycle, the definition is one complete pattern, and a period is the horizontal length to complete one cycle, which of course is one complete pattern. And of course the horizontal distance is the distance along the x-axis. So I'm going to keep all 3 of these words for you in the picture while I talk about this diagram that I have down below. So I'll use a red pen to talk about it. So you can see that this right here that I'm highlighting in red, this is a periodic function. Why? Because it repeats patterns of y values at regular intervals. Okay, so it has to be repeating the y values. A cycle could be here. This could be one. If I start here, I would go down and then go back up, and I'd get back to a starting point. So that is considered one cycle. You may also consider this in green one cycle. If I started here, went up, and then went down, and then went back up, that would also be one cycle. So it just depends on where you start and stop. So it can be anywhere. In this particular case, since I called this in red one cycle, the period is the distance along the x-axis that it takes to complete. So the distance would be the period would be from here to here. So we would measure that in units along the x-axis. So box number 1 is just an overview of all of the words that we're going to be using to talk about in this lesson. Okay, let's get an example for box number 2. The question is, what is the period for the following? It wants us to analyze the graph and then identify the cycle 2 different ways. So again, I will give you a red pen here. Let's talk about example A first. So one cycle could be, if I start here, I go down and then I go back up and I get back to my starting point. Okay, so it's asking us for what that period is. Remember, the period is the distance along the x-axis. So if I go from here all the way to here, I go 1, 2, 3. So in this case, the period would be equal to 3 units. Okay, whatever it happens to be. That's one way. Another way that I could do it, if I do this in blue over here, like let's say for example I started, I don't know, here. Then I would go up and then back down, and I would end up there. And again, the period is 1, 2, 3. 1, 2, 3. It would be 3. It has to be the same thing. So from here, the distance from here to here, again, is 3 units, okay? Or the distance measured from here to here, again, is 3 units, okay? A periodic function can't have a different period, so I just miscounted that first time. Okay, part B, here we go. Let's identify it 2 different ways. Again, I'll start in red. I'll pick a starting point at 0. So if I go up and then back down and then right back to where I started again, that would be one period. And that distance is 1, 2, 3, 4. So the period would be 4 units. If I started in a different location, like in blue, if I start here, for example, I would go down, and then when I get back to the same spot where I started, again, there would be 1, 2, 3, 4 units as well. So the period in this case would be 4. So no matter where you start and end, the period must be the same for periodic functions, and it can be described in a couple of different ways. That's what box number 2 is getting at for you. Okay, box number 3 is another example. It's asking us, is the function periodic? If it is, what is its period? Okay, I have A and I have B. Let's focus on A first. So if you look at A, many students are tempted to say that this is a periodic function because look, if I start here, then I follow this around, and I would probably end right about here. That looks like, and if I chop this up into 3 parts here, it looks like it's the same thing. And while the graph may be similar, remember the definition for periodic function is the y values have to repeat. So this y value right here never repeats anywhere else along the entire function. So part A is not a periodic function, okay? So be aware of that situation that comes up. In part B, I would think this one is periodic because check this out. If I start here and I follow the function here and then I go up and then I get to about here, I have a repeat of the y values, right? And then if I were to sort of break this up again, and then I would keep going. So this one is yes, and it is periodic, so I could definitely find the period. So it would be 1, 2, 3. Oh wait, sorry, this is 2, 4, 6, 8, 10. So the period in this case would be equal to 10 units, whatever those units happen to be. So A is not, and B is yes. Okay, box number 4 is a you try. Woohoo! Is the function periodic? If it is, write its period. Okay, hopefully you got the right answer, and the answer, of course, is yes. It is periodic because we have repeated y values, and therefore I could find the period, and I got 4 units, and I started here, and I highlighted it all the way out, and I'm back to where I started again, and that is a distance of 4 units. Box number 5 is another you try. Is the function periodic? If it is, what is its period? Okay, hopefully you guys got the right answer, and the right answer is no. The function is not periodic because there are no repeated patterns for y values. Even though it looks like this could be a pattern in the green box and this could be a pattern, and even though those patterns are similar, they do not repeat a pattern for y values. Therefore, it is not a periodic function. Tricky question. Okay, box number 6, we have more words for you. Here are the words. We're going to talk about amplitude and midline. First, amplitude is the amount of variation in the function values. So it's measured from the midline. So what that means is basically if I have a midline, how far to the top can I go and how far to the bottom can I go? And the way that you calculate it is you take the difference of the max and min and you divide it by 2. It's basically the average. That's what the amplitude is called, okay? The midline is the horizontal line that is midway between the max and the min values. So that should be pretty straightforward. So here's a little example for you. Okay, I have a periodic function. The midline is in purple for you, so I'll try and find my purple pen. Okay, the midline, it would be here. So I drew it right across because it is the mid distance between the max and the min. In blue for you, I have a maximum point here, and then I have a minimum point here. So the amplitude is going to be the distance from that midline to that high point or that low point. So it's going to be the same value. So to calculate that, we can just take the average of those if we needed to, or you can just look at the graph and figure it out. So amplitude and midline are also part of this conversation. Okay, number 7, find the amplitude and the midline for the following. Okay, well first let's make sure that we actually have a periodic function. So in green over here, I will start here and I will follow my pattern. I go down. And I'm not quite back to where I started yet. Boom, that's where I started. Okay, so I definitely have a, let me get rid of this thing over here. Sorry, guys. Okay, so I definitely have a periodic function. So the maximum point you can see is up here at 4. The minimum point is down here at 2. So that means that the midline has to be the difference of 4 minus -2, and then all divided by 2. 4 minus -2 is the number 6 divided by 2, which is equal to 3. So I can figure out exactly where my midline has to be in this particular case. Hey, sorry, I just realized I said midline. When I said 3, I meant the word amplitude. My bad. The amplitude is worth 3 units. Therefore, the midline has to be at 1, which would be this case here. So this is 1, this is 2, this is 3, this is 4. That's 0. That's -1. That's -2. So the midline would have to be right here. And that would be the equation y is equal to 1. And the reason is because the amplitude is worth 3 values. So if I go from there, 1, 2, 1, 2, 3, down, that would be my amplitude. And then again, this would be my amplitude here, down from there. So that distance and that distance are the same. That should be 3 units, okay? 1, 2, 3, there it is. So the midline is the equation y equals 1, and the amplitude is equal to 3. Sorry, I botched that for you. Okay, here is your chance to shine. Tell me the amplitude and tell me the equation for the midline. Remember, the amplitude is a value and the midline is an equation. Okay, hopefully you got the answer of amplitude is equal to 1.5 units, and the midline is the equation y equals -1/2. So how did I do that? First, I made sure that I had a periodic function, which I do, and then I figured out the max value is worth 1 and the minimum value is worth -2. So I did 1 minus -2, which of course is 1 plus 2 and 3 divided by 2. So I got 1.5 units as my amplitude. And again, the amplitude is the distance that's measured from the midline to the top or the bottom. So the midline would have to be at -1/2 in order to create 1.5 units from the top and the bottom. So there's a half and then there's 1 again. So this equation would be y equals -1/2. Hopefully that makes sense to you guys. And that's 13.1.